During beta decay, the electron is ejected from the nucleus. A. Write beta decay reaction for the neutron to proton transmutation. B. What happens when proton transforms to neutron? C. Does it violate the Heisenberg Uncertainty Principle that tells no electron exists in the nucleus? Before discussing question A, B, and C, let us discuss the types of beta decay in brief. So I'm writing types of beta decay. So beta minus decay, okay? Beta plus decay and electron capture. So we have this, okay? Now, in beta minus decay, okay? In beta minus decay, neutron converts to proton, beta particle, or electron along with anti-neutrino. So we have this, okay? This is neutron. This is proton. This is beta particle or electron, and this is anti-neutrino. So we have this, clear? And beta minus, okay, decay, or we can write in this way, beta minus decay occurs, it occurs with nuclide, okay, occurs with nuclide, for which n by z, okay, is too large. So we have this. So this represent, or this is the solution, okay, of question A. So when we are asked to write beta decay reaction for neutron to proton transmutation. So neutron to proton transmutation is beta minus decay, okay? So I'm writing over here. Neutron to proton transmutation, okay? Transmutation is beta minus decay. So this is to be noted, okay? So we have this. And this is the beta decay reaction, okay? So we have this. Now, solution for B. Okay, what happens when proton transforms to neutron? So when proton transforms to neutron, it is beta plus decay. Okay, so I'm writing over here. Proton to neutron. Okay, proton to neutron transmutation is beta plus. Okay, it is beta plus decay. So we have this. Okay, and this process, okay, proton transform or is converted to neutron, positron, okay, beta plus, and electron neutrino. So we have this. Okay, so we have this. Okay, this is proton, this is neutron, and this is electron neutrino. So we have this, and beta plus decay. Okay, so I'm writing over here beta plus decay occurs, okay, when mass of the original neutral atom, okay, is at least 2 electron masses larger than that of final atom. So we have this. Okay, so this reaction represent, okay, it represent proton to neutron transmutation. So we have this. Okay, clear? Now in electron capture, okay, so I'm giving the concept. We have this proton and beta particle. Okay, so we have this proton and electron. Okay, so we have this combine to give neutron along with electron neutrino. So this represent electron capture. Okay, and electron capture, so I'm writing over here electron capture occurs when mass of the, okay, mass of the original neutral atom is larger than that, okay, of the final atom. So we have this, okay? Now, let us discuss electron capture more, okay? Now, there are few nuclides, okay? Nuclides for which beta plus, okay, emission is not energetically, okay, possible. So we have this, but in such nuclides, so I'm writing directly, okay, in such nuclides, orbital electron, that is electron in K cell, okay, usually electron in K cell can combine, okay. So we know in electron capture, okay, we have this proton and beta minus, that is electron combine, okay, to give neutron along with electron neutrino. So I'm writing can combine with a proton, okay, proton in the nucleus, to form neutron and neutrino or electron neutrino, okay. So I'm writing in this way, in short, okay. Clear? We have this electron neutrino or simply neutrino. The neutron in electron capture, okay, we find this, the neutron remain in the nucleus. It remain in the nucleus and neutrino is emitted. So we have this in electron capture, okay. Now let us discuss question C, okay. So let us see what is question C. Does it violate the Heisenberg Uncertainty Principle that tells no electron exists in the nucleus? Now we know in beta decay, okay. So in beta decay, in this process, okay, in beta decay, we find electron is ejected, okay. So I'm writing in beta decay, okay, we find this, okay. So I'm rewriting the equation. We find neutron is converted to proton, beta particle, that is electron, okay. This is electron and anti-neutrino. So we have this, okay. So we have this. So I'm writing during beta decay, okay, during this process, electron is ejected, okay, from the nucleus. So we find this, okay. Let's see the question once again. Does it violate the Heisenberg uncertainty principle that tells no electron exists in the nucleus. Okay, so we find this electron in this decay. Okay, so we find this it does not, okay, it does not violate, it does not violate, it does not violate the Heisenberg uncertainty. Okay, Heisenberg uncertainty principle that tells no electron exists in the nucleus. Okay, electron, so we can see electron is emitted, okay, in this process or in this decay process. So it seems that electron is ejected from the nucleus. Okay, so it seems, I'm telling, it seems that electron is ejected from the nucleus. So I'm writing electron do not pre-exist. This is to be noted. Okay, electron do not pre-exist inside the nucleus. So this is to be noted. Okay, they are created. Okay, electrons are created when neutron change to proton to have conservation of charge. Let's see this. Okay, neutron, we have this, clear? Proton, we have this, and we have electron. Okay, so and this reaction, okay, number of charge on left hand side equals to the total number of charge on right hand side. We can see charge on left hand side, okay, is 0, and when we add charge of proton and charge of electron, then we get 0. So the number of charge on left hand side equals the number of charge or total charge on right hand side. So we have this. Okay, there is no violation of Heisenberg uncertainty principle. Okay, there is no violation of Heisenberg uncertainty principle in this process, okay, or in beta decay.